topic for today is adding and subtracting rational algebraic expressions. The very first thing to do in adding and subtracting rational algebraic expressions is check the denominators. Why? Because we have different steps to take if the denominators are similar and if the denominators are not similar. For rational algebraic expressions with similar denominators, simply add or subtract the numerators and copy the common denominator. But for rational algebraic expressions with denominators that are not similar, you have to find the LCD or the least common denominator and transform the expressions into having similar denominators. Then proceed to addition or subtraction. The question now is, how do we find the LCD? LCD or least common denominator is the LCM or least common multiple of the denominators. For example, if 16x cubed and 24xy are the denominators of the expression, what is the LCD? So just like what we did in finding the GCF, we will also use a grid in finding the LCM. Think of a number where you can divide both 16 and 24. For example, you thought of 2. So let's just write 2 here and then divide 16 by 2. The answer is 8. And then 24 divided by 2, the answer is 12. Then, by what number can we divide both 8 and 12? Let's have 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. 2 and 3 do not have any common factors except 1, so we will just multiply the common factors at the left by the uncommon factors at the right. Notice that we have the L shape. So that's 2 times 4 times 2 times 3, and it is equal to 48. In GCF, we do not include the uncommon factors, but for LCD, uncommon factors are included in the final multiplication. So now, how about for the variables x cubed and xy? For this, we have to look at the common factor and choose the one with the greater exponent. The common factor is x and the higher exponent is 3. So we choose x cubed. Then we will multiply this by the uncommon variable or uncommon factor y. So the variable part of our LCD is x cubed y. Multiply it by 48. So the LCD of the expressions is 48x cubed y. Now, let's see the next example. If x plus 2 and x plus 5 are the denominators of the expression, what is the LCD? There are no common factors except 1, so we will just multiply x plus 2 by x plus 5. So, our LCD is the product of the binomial x plus 2 and the binomial x plus 5. How about if the binomial x plus 2 and the square of x plus 2 are the denominators of the expression? What is the LCD? The common factor is x plus 2 and the higher exponent is 2. We take the higher exponent, so the LCD is the square of the binomial x plus 2. Next, if the binomial x plus 2 and the binomial x squared minus 4 are the denominators of the expression, what is the LCD? X squared minus 4 is factored as the product of x plus 2 and x minus 2. It seems that the denominators became like that. So x plus 2 is a common factor, and we will multiply this by the uncommon factor x minus 2. Therefore, the LCD is the product of x plus 2 and x minus 2. Those are just a few examples of finding the LCD, and aside from the LCD, you should also have this big reminder. Always present the sum or difference in simplest form. Let us now have the examples of adding and subtracting rational algebraic expressions. The first one is find the sum of 3 over 6b and 1 over 6b in lowest term. Sum means addition. So we will add the two expressions. Let us check the denominators. Are they similar? Yes, they are similar. So simply add the numerators and copy the common denominator. So we copy 6b as the denominator of the sum. Then let's add 3 and 1 as the numerator. Simplifying further, 3 plus 1 is equal to 4. So the answer is 4 over 6b. Reminder, check if the answer you got is already in its simplest form. How can I say that's already in its simplest form? Ask yourself, do the numerator and the denominator have common factors? In our answer, 4 and 6 have common factor. That's 2. So let's factor out 4 as 2 times 2 and 6b as 2 times 3 times b. 2 divided by 2 is equal to 1. So what remained in the numerator is 2 and in the denominator 3b. Therefore, the final answer in simplified form is 2 over 3b. Next example, add x over the binomial x squared minus 4 and 2 over the binomial x squared minus 4. Let us now check the denominators if they are similar. Yes, they have similar denominators. So we will just add the numerators and copy the common denominator. Then let's add x and 2 as the numerator. The sum is now x plus 2 all over x squared minus 4. Again, reminder, check if the answer you got is already in its simplest form. Do the numerator and the denominator have common factors? The denominator x squared minus 4 is difference of two squares. So it can be factored as x plus 2 and x minus 2. The numerator x plus 2 divided by x plus 2 is equal to 1. So what remained in the numerator is 1 and in the denominator x minus 2. Therefore, the final answer is 1 over the binomial x minus 2. Let's have example 3. Simplify. Again, we have to check the denominators if they are similar. They are similar. So simply add the numerators and copy the common denominator. Let us copy the denominator x squared minus 4 and let us subtract the binomial negative 3x minus 1 from the binomial negative 2x plus 1. Please note that a binomial preceded by a minus sign shall be multiplied by negative 1. That is why negative 3x minus 1 became 3x plus 1. Negative 3x times negative 1 is positive 3x. Negative 1 times negative 1 is positive 1. Now, let's combine like terms. Combine negative 2x and positive 3x, then combine positive 1 and positive 1. So, the numerators became like that. Then, negative 2x plus 3x is x and 1 plus 1 is 2. So, the numerator is now x plus 2. Then, check if the answer is already in its simplest form. Do the numerator and the denominator have common factors? Again, the denominator x squared minus 4 is difference of two squares. So its factors are the product of x plus 2 and x minus 2. The quantity x plus 2 divided by x plus 2 is equal to 1. Therefore, the answer is 1 over the binomial x minus 2. How about in this fourth example? Find the sum of 2m over n minus 1 and 3 over m plus 4. So again, this is sum. So we will add 2m over n minus 1 and 3 over m plus 4. Look, the denominators are not similar. So we will find the LCD, then change the expressions into having similar denominators. The LCD is the quantity m minus 1 times the quantity m plus 4. That will be our new denominator. The new denominator will be divided by the old denominator. Then that will be multiplied by the old numerator. So, our LCD will be divided by the old denominator m minus 1, and that is equal to m plus 4. So 2m will be multiplied by m plus 4. Then the LCD divided by the old denominator m plus 4 is equal to m minus 1. And we will multiply this by 3. There. Simplifying further, 2m times m is 2m squared, 2m times 4 is 8m, 3 times m is 3m, and 3 times negative 1 is negative 3. Then, combine like terms, 8m and 3m. The numerator will become 2m squared plus 11m minus 3. Reminder, check if the answer you got is already in its simplest form. Check if 2m squared plus 11m minus 3 can be factored. So here, the product of A and C is negative 6, and we have to think of the factors of negative 6 that will add up to positive 11. No set of factors for negative 6 will add up to positive 11. So we will just retain the numerator that way, and then, to make the expression simplified, we will multiply m minus 1 by m plus 4. And this is the final answer. And for example number 5, find the sum of these expressions. Look at the denominators. They are not the same, so let us factor them to be able to find the LCD easily. As you can see, the factors of x squared minus 4 are x plus 2 and x minus 2. Then the factors of x squared minus 5x plus 6 are x minus 3 and x minus 2. Their common factor is x minus 2, so this is the LCD. Then let us divide the LCD by the old denominator, then multiply this by the old numerator. So LCD divided by the old denominator, x plus 2 times x minus 2 is x minus 3. So let us multiply x minus 3 by 6. Then LCD divided by the old denominator, x minus 3, x minus 2 is equal to x plus 2. So x plus 2 is multiplied by 2. Simplifying further, 6 times x is 6x. 6 times negative 3 is negative 18. Then 2 times x is 2x. And 2 times 2 is 4. Now let us combine like terms. 6x plus 2x is 8x. And negative 18 plus 4 is negative 14. Then let us check if the numerator and denominator still have common factors. The numerator can be factored as 2 times the quantity 4x minus 7. So no common factor with the denominator, so let's just put back 8x minus 14 and multiply the set of binomials in the denominator, which is also the same as x squared minus 4 times x minus 3. And now this is the final answer. Example 6. Look at the rational algebraic expressions. They are not similar, so let us factor the denominators. The product of AC is negative 6, and the factors of negative 6 that sum up to 5 are positive 6 and negative 1. The GCF of 2 and negative 1 is 1. 2 divided by 1 is 2. 6 divided by 2 is 3. And negative 1 divided by 1 is negative 1. Therefore, the factors of the first denominator are 2x minus 1 and x plus 3. For the next denominator, the product of AC is 10. What factors of 10 sum up to negative 11? These are negative 10 and negative 1. The GCF of 2 and negative 1 is 1. 2 divided by 1 is 2. Negative 10 divided by 2 is negative 5. Negative 1 divided by 1 is negative 1. So the factors of the second denominator are 2x minus 1 and x minus 5. Looking at these factor denominators, let us now find the LCD. So the LCD is the product of 2x minus 1, x plus 3, and x minus 5. Then, same process as earlier, we divide the LCD by the old denominator, then multiply by the old numerator. Here are the answers to the division processes. The numerator shall be written like this. Then simplify. 5 times x is 5x. 5 times negative 5 is negative 25. Negative 3 times x is negative 3x. And negative 3 times positive 3 is negative 9. Now combine like terms. 5x minus 3x is 2x. Then negative 25 minus 9 is negative 34. Now let us check if the numerator and the denominator have common factors. 2x minus 34 can be factored as 2 times the binomial x minus 17. But it has no common factor with the denominator that we can divide. So let's just have 2x minus 34 and multiply the binomials in the denominator. So here's the final answer. Last example, we have to add. Look, the denominators are not similar, so we will factor them again. Based on their factored form, you can see that this is their LCD. Then, divide the LCD by the old denominator, then multiply by the old numerator. Here are the answers in the division process. So we write the new numerator like this. Then combine like terms. 3x squared plus x squared is 4x squared. Then we have negative 3x minus 4. Check if the numerator and the denominator can still have common factors. 4x squared minus 3x minus 4 cannot be factored anymore because there are no factors for negative 16 that will add up to negative 3. So let's just retain that numerator and then multiply everything in the denominator. So that's it. That's the final answer. Now, try to complete these solutions on your own. Napansin ko kasi laging ako na lang ang nagsosolve. So dito, tulungan ko kayong isolve by giving you this guide para malaman ko rin kung talagang naunawaan nyo. First, are the denominators similar? What is the denominator of the sum? What will you write on the numerator of the sum? And how can you simplify? Here's the final answer. Do you think that's the answer to the solution that you made? How about this? Check again the denominators. Are they similar? So what is the denominator of the sum? The numerator has been written this way for you. How will you further simplify? Like terms have been grouped together. So what is now your final answer? Remember to check if the answer is already in simplest form. Next, find the sum of 3 over 2a and 1 over 6a. Sum means addition. Kindly check the denominators. Are they the same? So you have to find the LCD. Now I've given you this LCD already. What is the missing number in the numerator? Use this as your guide. Then simplify. Then look, the numerator and the denominator have common factor which is 2. How will you complete it? So what's the final answer? So last one, look at the given rational algebraic expressions. Are the denominators the same? What will you write on the denominator and on the numerator? What is the final answer given this clue? So that's the last part of our video, and I hope this helps you in learning addition and subtraction of rational algebraic expressions. Thanks for watching. Bye!